First order ordinary differential equation.
All right, class. So today we'll be looking at the first order ordinary differential equation. The first order ordinary differential equation. All right. So now, when we started with the differential equation, we said that there are two classifications of differential equation. We have the ordinary differential equation, and we have the partial differential equation. So in this particular video, or in this particular lesson, we want to look at the first order of what? An ordinary differential equation. And we said ordinary differential equation will have only one independent variable. For ordinary differential equation, they will have only one independent variable. And the PD you have two or more independent variables. The PD will have two or more independent variables. All right. So now, when we say something is a first order, we've been dealing with first order, second order, first order. But in this particular one, we are only considering the first order differential equation. That is to say, the highest derivative of the differential equation should be 1. That is what? The first order differential equation. Now, how do you know it? Anytime you look at the first order differential equation, you want to look at the differential equation in two forms. You look at the differential equation itself in two forms. Now, the two forms we look at it, one. We look at it one in a standard form, and two, we look at it in what? In the differential form. We look at the ordinary differential equation one in a standard form, and two, we look at it in what? The differential form. So in a standard form, you have a function of xy and y dx that is equal to 0. Or sometimes in other books you see function of x and y, comma y prime is equal to 0. So the y prime I've already stated that is the same as what? The dy dx. So now if you want to find the y prime for the standard form, the y prime then becomes the function of what? The x and the y. The y prime is simply what? The function of the x and the y. So you're solving for the ordinary differential equation. This is something what you will be getting. And a typical example under the standard form is when you have y prime plus y all cubed is equal to the sine of y prime on what? On x. So this is a typical example under the standard form. But we will be dealing much on the differential form because we are talking about, or the lesson is about differential equation. So we will not go into the standard form. A lot of explanation to the standard, but it's the same thing. We just transfer the standard form idea to a differential form so that we can resolve it with the differential idea. All right. So in the differential form, what happens is that you have m of x and y with respect to the derivative of x plus n x and y with respect to the derivative of y, which is equal to 0. So now we divide the function into two. So here our focus was to find dy dx in the standard form. So we are always ready to find the derivative of what? Dy dx in the standard form. For in the standard form, this is our focus. And this is a typical example. When you make the dy dx the subject, then you solve the equation. That's the first order, you solve the equation. So here our focus was only to find the dy dx. Now, here too, our focus is to find the dy dx. But how do we do it? We just have to find a way to make the dy dx the subject of the equation. So how do we make the dy dx the subject of the equation? We can say m of what? xy dx is then equal to what? So when this is coming out after it becomes negative n of what? X, y, y. All right. So now when you are given any question, you just have to put the question in this form. What is the function of x and y with respect to x, and n? What is the function of also x and y with respect to the y? And after that, you have to make the dy and the x the subject of the equation. So now, when you divide here by the x, the x will take the x away. So you get what? M of what? Xy which is equal to negative n xy dy over dx. So here, when you make y the n the subject, you divide it by the function of this, and divide it also by the function of n xy. So this also will take this away, and finally you get your y dx, which is equal to negative n of the functions f of x, xy divided by n xy, and that will be, so this is in the differential form. This is what you are looking for in the differential form, and this is what the standard form. All right, let's look at how we can find solutions to a first order differential equation. Now, in finding solutions to a first order differential equation, there are many methods we can go by. Now, first of all, basically, we start with the method of what? Separation of variables. The method of separation of variables. Now, with the method of separation of variables, it works simply for homogeneous functions, some functions that are homogeneous, and also it can work for some functions that are not homogeneous. Are you getting it? So now what happens is that there are some differential equations when you are given, they are straightforward. So you can just use your separation method and you just do it. But there are some questions too, they are cumbersome or they are complex. So you have to reduce it to the separation form so that you can use your method of the separation of variables and you find your dy and dx of the equation. We're only dealing with first order, so take note of that. All right. So now with this video or like this lesson, we want to look at the method of separation of variables in the first concept, where you don't need to reduce any cumbersome equation to the separable form. But in the next video, we look at how we can do those kind of reduction to a separable form. All right. So now, with the solutions to the first order differential equation, solutions to the first order differential equation. Okay, so now we are using the method of separation of variables. The method of separation of. All right, so now, how do we do it? First of all, you have the differential forms of equation. You are not dealing with the standard form as we said earlier. The x plus n of xy dy is equal to 0. So this is already a differential form of equation of a variable. Now, when you are given a question, how do you find or how do you get a solution to the first order differential equation? All right, let's consider an equation of this nature: m of x multiplying n of y with respect to what? The x. M of x multiplying n of what? The y with respect to x, the x, plus p of x multiplying k of y with respect to dy is equal to 0. Now, let's look at this equation very well. M of x with respect to n of y with respect to the x, p of x, p of y with respect to the y. Now, so let's take this as an equation 1. Let's do this as an equation 1. So this is a question, a typical question you have been given. It's not a typical question, but I mean this is how the question should be. All right. So now, when you have this and you want to find, the focus is to find your solution to this first order differential equation. You've already studied the general solutions already. But if you have a equation and you want to find your solution to the first order differential equation, what happens is that we have to get a set of values that will only be respect to y. So when you look at this page very well, you realize that there is a function with respect the function of x over here, and yet there's a function of y over here with respect to x, and there's the function of x here with respect to y. So you have to find a way to eliminate those functions so that functions of y will be with respect to y, and the functions of x will be with respect to what? With x. Alright, so now when you take the equation 1, we can divide equation 1 by, so we divide the equation 1 by n of function y and p of function what? X. Alright, so now you divide both sides. So you get m of x, n of y, all divided by n of y bracket p of x dx plus into bracket you have p of x k of y all divided by n of y plus n of y multiplying p of x dy is equal to 0. So now, when you do this division, what do we get over here? You realize that finally the y can take the y away, and yet the p of x can take the p of x away. So what do you get? You get your m of what? Your x over what? P of x dx plus your q of y all divided by your n of y dy is equal to 0. So now when you have something like this, then you can easily find your integral of what? Your m of x over the p of x dx to get away the derivative of the x plus the integral of your q of y divided by your n of y dy to get away the derivative of the y is equal to an arbitrary constant c, because anytime you do an indefinite integral you get an arbitrary constant which is a constant c. Alright, so let's take a typical example and look at how we find the solution. So this is simply the method of what? Separation of variables. Alright, so find the solution to this equation x plus 1 dy dx, which is equal to x into bracket y squared plus 1. So this is a typical question, and you have been asked to find the solution to this first order differential equation. So now with this question, for instance, we are trying to get find the general solution for this particular question. And to find the solution to this first order differential equation, you have to eliminate the dy dx from the equation. You have to eliminate the dy dx from the equation. Alright. So now what happens is that when you look at the function, you have to find a way so that all the x variables will be with respect to the x, and all the y variables then will be with respect to the y. That is the only trick over here. So with doing this, you can multiply both sides by, yes, so you get x plus 1 dy over dx dx, which is equal to x into bracket y squared plus 1 dx. So you multiply both sides by the x. So the x will take the x away. So we get x plus 1 dy, which is equal to x into bracket y squared plus 1 dx. Alright. So now what happens here is that we can divide both sides here by y squared plus 1, y squared plus 1. So you divide both sides by y squared plus 1 and x plus 1. And divide both sides also by x plus 1. So divide both sides by y squared plus 1 and what? X plus 1. Alright. So now when we do this, what are we getting? We hear that x plus 1 will take this x plus 1 away, and y squared plus 1 will take y squared plus 1 away. So what do we get? We now get 1 over y squared plus 1 dy, which is equal to x divided by x plus 1 what? Dx. X divided by x plus 1 dx. So now when you get this function, you are true to go because you can now find the derivative. So y with respect to the y, x with respect to the y. So you can find the integral 1 over y squared plus 1 dy is equal to integral of what? X divided by x plus 1 dx. Alright. Now, to make this very, very simple for you, when you bring the integral, let's take them outside so that you can have a constant. So let's say x over x plus 1 dx, and this one comes to be minus 1 divided by y squared plus 1 dy, which is equal to a constant c, because of what? It is an indefinite integral. It is an indefinite what? Integral. Now x divided by x plus 1, to easily be able to integrate it, let's change it. So x divided by x plus 1 is the same as 1 minus 1 divided by x plus 1. So now x divided by x plus 1 is the same as 1 minus 1 divided by x plus 1. So you can just verify it. I'm getting it. So now 1 minus 1 divided by x plus 1 dx minus integral of 1 over y squared plus 1 y is equal to the arbitrary constant, which is what? Which is c. Alright, so let me clear this place. And let's finish it up here. Alright, so now what happens is that you can now integrate the constant. So if you integrate 1, you get what? X. With respect to the x, you get x. And now when you integrate 1 over x plus 1, it is equal to what? The lane of what? Of x plus 1. That is to say, this is the simple thing, but I think you should get it. Anytime you have maybe 2 divided by y squared plus 1, and when you differentiate the down here, you'll be getting the constant here on top. Then it's simply, the integration of it is simply what? Lane of what? The y squared plus 1. So anytime you integrate down here, and the answer you get is what you have as your numerator. Anytime you differentiate your denominator, and the answer you get is what you have as your numerator. When you find the integral, it is equal to the length of what? The denominator. Right? It is equal to the length of the denominator. So anytime that is the trick. When you are solving a lot of questions, you should know how you deal with it, right? Okay. So now, what happens is that if you do this one will give you minus what? The length of what? X plus 1. And now anytime you have 1 over a squared plus 1, you have 1 over a squared plus 1. It is equal to what? The tan inverse of what? Of the a. It is equal to the tan inverse of the a. So anytime you are integrating 1 over what? A squared plus 1 is equal to the tan inverse of what? Of a. Your integration and your differentiation in school, in your high school, you should take very good care of it. So here you get what? Minus tan inverse of what? Of y. And that is equal to what? C. So now this becomes your general solution for this particular differential equation. So you've been able to get rid of what? Our dy and our dx by our integral factors. Alright. Let's take one more example. So let me just put the answer here. So we have x minus ln of x plus 1 minus tan inverse of y is equal to c. Alright. Now example 2 says that our dy of the x is equal to x squared divided by y plus y multiplying 1 plus x cubed. Okay. So this is 8. And this is also very simple. How to make the y on this one. So let's y over the x. So in simple terms, let's multiply this side by the x and this side also by the x. So we'll take away. Alright. So now when you do that, what do you get? You get your dy is equal to x squared over y 1 plus x cubed what? The x. So now you can multiply side by y. So you multiply here by y and multiply here by y. Y will take this away. Alright, so when you do that, so this is a multiplication. So the y will take this y away. So you get y dy is equal to x squared divided by 1 plus x cubed to what? The x. So now when you get something like this, you can easily now take your your integral. So you can take your integral of your y. The y is equal to the integral of what? The x squared 1 plus x cubed dx plus c. So you just bring the arbitrary constant, and that one doesn't matter. Alright. And take note that sometimes when you are solving the question and they give you the option, they'll be like, after the end of the whole calculation, they'll be like plus what? A. It's the same as the arbitrary constant, right? Alright. So you should take note of that. Alright. So now when you get this, when you integrate this of y dy, you get half of what? Y squared. You get half of y squared. When you integrate y becomes what? 1 plus 1 divided by what? 1 plus 1, which is equal to y square on what? On 2. So that's the integration. When you integrate y with respect to y, you get half of what? Y squared. And also when you integrate this, to make this integration very simple, this is how you can do it. You realize that to integrate this, when you integrate when you differentiate the down one will give what? If you differentiate 1 plus s cubed, you get 3x squared plus 0. So when you differentiate the down one, you get this one. So now we should find a way to make the numerator something like this, so that it will not affect the equation itself. If you find a way to make the numerator something like this, then you can easily find the length. You can easily take the length of what? The differentiation. So this is the trick. So now how do you do it? You realize that our s squared is already top here, so it's not a problem. So you can just introduce 3x squared, a multiple of 3 here, and you multiply it also by 3, 1 plus what? Our s cubed, the x plus what? Arbitrary constant c. So now when you do it this way, what you can do is that you can take this 3, this 1 on 3, so it's more or less like 1 over 3. So you can just take this 3 here as a constant, and you find the integral of what? The 3x squared into brackets divided by 1 plus s cubed what? The x plus what? C. And now the moment you do this, what happens is that when you differentiate this place, you get what is on top. So it simply becomes a length. It's the same equation as this. Those who are confused, who might be confused, because the 3 can take this 3 away and still get back this. So we just introduce it to make our integration very faster. So we have our half y squared, which is equal to our 1/3 length of what? 1 plus what? S cubed plus our arbitrary constant, which is what? Which is c. So now to find y, you can just decide to find. If you want to find y, it's simply equal to what? So you can take square root over here. So you simply got to. Okay, before you can find the y, you multiply here by 2. You multiply the whole of this also by 2. So the 2 take this away. So you get y squared, which is equal to 2 on 3, length of what? 1 plus s cubed plus what? Your 2c. 2 times the arbitrary constant. And now the moment you do this, you can easily find your y. So you find the square root here, find the square root over. So you get your y as what? Plus or negative square root of what? 2 on 3, length of 1 plus s cubed plus 2 times the arbitrary constant. So now, in some final answers, you can have it as y as what? Your 2 on 3, length of what? 1 plus s cubed plus what? A plus A. So you should know that the arbitrary constant sometimes you shouldn't make it confusing. The main point is having these expressions over there, and this becomes the solution to this one. So this is how you go about with what? The separation of what? Variable. So you separate the x variable on one side and you separate the y variable also on what? On one side. Thank you very much, and let's move on to how we do the reduction of separable forms.